Now, you guys, you come to the problem 79 of your textbook. The figure is shown. From the figure itself is clear that this is a circular path or cylindrical path, and this is a linear path but inclined. And a small ball is at a height capital H. A small ball of mass m, so it has got mass m. Rolling in the loop track, the ball is released from the point height H, the lowest point. The circular part has a radius r. Good, it has got a radius r. Find the kinetic energy of the ball when it's at a point A, where the radius makes an angle theta with the horizontal. So diagram is very clear. I hope you have no doubt in the diagram. So find the kinetic energy of the ball when it is at A. Of course, uh, there is no doubt kinetic energy of the ball at A will be the difference of potential energy between the starting point and the final point. There is absolutely no doubt in that, right? So, what is the potential energy at A? So, potential energy at A is equal to, this height is r sine theta. R sine theta, and this height is r. So potential energy at A is mg r plus r sine theta. Mg r plus r sine theta. And what was the potential energy at this point? Say, let us give it a name P. Potential energy at P was potential energy at P was mgh. So, without any further confusion or doubt, we can write, so kinetic energy at A is equal to potential energy at P mgh minus mg r plus r sine theta. We have no doubt in that, which you can write in the form of mg within bracket h minus r minus r sine theta. So this is your answer to the part A. Answer to the part A. Second part is, find the radial and tangential acceleration of the center of mass of the body when it is at A. That means we have to find out the radial acceleration, which is equal to v square by r, and tangential acceleration is A, right? So going to part B, we will do it this way, part B. Kinetic energy of rolling, pure rolling, we have done it earlier, is 7 by 10 mv square, right? If tangential velocity at A is equal to V, then kinetic energy due to pure rolling, is equal to 7 by 10 m v square. I am not doing it once again because I have done it in just in last example. Kinetic energy of pure rolling is 7 by 10 mv square. So 7 by 10 mv square is another expression of kinetic energy that we have already got. So 7 by 10 mv square is equal to mg h minus r sin theta. Here you cancel m and m. So you have v square equal to, so v square is equal to 10g by 7, 10g by 7 within bracket h minus r sin theta. And what is the radial acceleration in any circular motion? You recollect your lesson from the circular motion chapter. Radial acceleration in a circular motion is v square by r. So we can write, so radial acceleration is equal to v square by r is equal to 10g by 7r h minus r sin theta. They wanted us to find out the radial acceleration, so this is the radial acceleration. Now they want us to find out the tangential acceleration. How do we find the tangential acceleration? Also, it will be another simple step. Tangent, so from this equation, I write here, say this is equation 1. From equation 1, you can write, this was v square by r is equal to this. So we can write v square equal to we multiply right hand side by r. So this r and this r gets cancelled. So it is 10g by 7 equal to 10g by 7 h minus 10g by 7 r minus 10g by 7, this r will remain here, 10g by 7 r sin theta, 10g by 7 r sin theta. Now we differentiate this equation on both sides. Differentiating on either side, we write differentiating on both sides. On the left-hand side, the differential will be on t, time. On the right-hand side, it will be on theta. Differentiating on both sides, what we find? 2v into dv dt is equal to differentiation of 10 by 7 gh is 0 because it is neither a function of t nor a function of theta. So it is 0. Second one is also 0. Minus third one is 10 g r by 7. 10 g r by 7. Differentiation of sine theta is cos theta d theta. Fine. Now, dv dt is equal to a. Now, dv dt, that means time derivative of the linear velocity is equal to acceleration a. Also, dv dt is acceleration a, and this is, sorry, cos theta d theta dt. Because on both sides, I am differentiating with theta. Differentiating on both sides with respect to time. Let me write it. With respect to time. Then it will be clear. So the right hand side will be sine theta, derivative will be cos theta d theta dt. So here dv dt is a, this one dv dt we know, and dv dt is a, and d theta dt is equal to omega, and also v, this v, and v is equal to, we know, is omega r. Considering these equivalences, so this is 2 multiplied by v becomes omega r, dv dt becomes linear acceleration a, is equal to minus 10 g r by 7 cos theta, and d theta dt is omega. Cos theta multiplied by omega. Now here, this 2 gets cancelled with 10. We are left with 5 here. So what we are left with is a is on the left hand side. Also, this omega and this omega gets cancelled. This r and r gets cancelled. So we are left with a is equal to minus 5 by 7 cos theta. Minus 5g by 7 cos theta. So linear acceleration a is equal to minus 5g by 7. This is they wanted us to find out the radial and tangential acceleration. So this was the radial acceleration, and this is the tangential acceleration. Now this question has a third part which says, find the normal force and the frictional force acting on the ball when some values are given. Normal force and frictional force. Look, what they really want us to find out is when the body is actually at A, actually at this point, because it is given when theta equal to 0. It is given when theta equal to 0. When body is at this point, what is the normal force and frictional force. That means what is the normal force and what is the frictional force. These two forces they want us to find it. We can find it this way. The normal force is mv square by r. We know that, so we don't have to bother anything about this. Normal force, C part. Normal force is equal to mv square by small r or capital R, mv square by r is equal to, it is capital R, not small r. As the capital R is the radius of the rotation. Normal force is mv square by r equal to m. Mind it, we found out the value of v square by r as we found out the value of v square here. Found out the value of v square here, 10g by 7 h minus r sine theta. So this is m by r multiplied by 10g by 7, 10g by 7 multiplied by h minus r sine theta. Now these values are given. Values are given. M is given as, let us see here, M is given as, I think M was given as 70 gram. Yes, M is given as 70 gram. M is given as 70 gram, theta is 0, R 10 centimeter, and H 60 centimeter. So we have to just put these values here. M is 70 gram, means 0.07. R is also given. R is given as 0.1 meter, 0.1 multiplied by 10. G, we take 10 once again, divided by 7 was always there, 7. H is given 60 centimeters, so 0.6 minus R is given 0.1 and sine theta is sine 0 equal to 0. If you calculate this, you will find its value is 5 Newton. So this is the normal force acting on the body. What is the tangential force acting on the body? Now, for the tangential force, here the mg force acts downward and the acceleration is negative because from here the deceleration starts. So we can say the direction of acceleration here, and this is the direction of the frictional force F. So from this here we get mg minus F equal to ma, or F equal to mg minus F, or frictional force F equal to mg minus ma. Now you have to just put the values. mg minus ma, and this is equal to m into g minus a. The value of a we have got earlier, 5g by 7 cos theta. This is m is now given 0.07 kg. G we consider 9.8 minus A is already available here, 5g by 7, 5g we take 9.8 by 7 into cos theta is cos 0 degree. If you calculate this, you will find this is 0.196 Newton. So this is the frictional force that they want you to find out. Right? Now we shall go to the next question.